Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see the problem house robber. It's a continuation video of my previous video where I discussed the same problem with the brute force and then optimized the solution with dynamic programming memorization approach. Now in this video we will talk about the tabulation approach. So I will paste the description, I will paste the link of the video of the previous video in the description link of this video. Please go through that video and then we can continue with this video. So let's see the example 1 2 3 1. So here we will be using tabulation approach for the same problem. So what does tabulation approach means? Bottom up approach. I mean, we have the solution for smaller problems and the solution is optimal, and using those optimal solutions we will find the solution for larger problem. In the previous video we saw that that our base condition was dp0 equal to nums of 0, right, which meant that the smallest, now this will be the smallest optimal solution in case of tabulation approach, and we can verify that. How? If we have only one house, what is the maximum amount we can rob is the amount stashed in that house, so it will be 1. So for dp of 0, what will be the max amount we can rob is 1. Now for dp of 1, so this is index and this is money. So for dp of 1, we have to take the maximum of two things. First, so we'll take the max of 1 is nums of I, like nums of 1 plus dp of 1 minus 2 or dp of 1. But as we know, dp of 1 minus 2 is not there, so we'll take it as 0 or will not perform it, whatever we can do. So now it will be max of nums I is 2. Nums I is 2, that is the amount in that house, or dp of 1 is 1. So what is the max is 2. So dp of 1 is 2. What is dp of 2? dp of 2 again max of nums 2 comma d plus dp of nums 2 plus dp of nums 2 plus dp of 2 minus 2 or dp of 1. So this is the condition when we rob the current house. We can rob the current house, so we will rob the house which is I minus 2, which is 2 minus 2, that is 0, or we can rob this house. So both the possibilities, and now we'll take the maximum. So maximum of nums 2, that is 3, plus what is dp 2 minus 2, dp of 0 is 1 or dp of 1 is 2, which is the max. So dp of 2 is 4. Now let's calculate dp of 3. So let's calculate dp of 3. Final dp of 3. So dp of 3, again we are at index 3, what we can say, either we can rob the current house, so means it's nums of 3 plus dp of 3 minus 2, right? Or I can rob this house, or dp of 2. I can leave this house and I can take only this house. So now the max of nums 3, that is 1 plus 3 minus 2, that is 1, 2. And what is dp of 2? That is 4. So what will be the maximum? Maximum will be 4. So dp of 3 will be 4. And as we know in the tabulation method, the dp of n, the final element, returns our answer. So dp of 3 will be returning our answer, that is 4. Also we can verify, if you see this is evident, if we take 1 2 3 1, 1 plus 3, 1 plus 3, 1 2 3 1, 1 plus 3 will give you the optimal, the maximum loop, the maximum money. So this is the way, this is the tabulation approach. Now let's see the program for it. So we'll initialize our nums.length as n. We initialize a dp of size n, and then we'll call a helper method rob. Now we will initialize dp of 0 as nums of 0, our smallest optimal solution, and then we proceed further from smaller to the nums.length. So we'll start from I equal to 1 and go till nums.length. So we have to two things, we have the two choices, right? Either we can take the current, I can rob the current element, always I can rob the current element plus I minus 2. That is what we are doing, rob the current element, nums of I, I'm storing it to take, and then again if I is greater than 1. So first I'm taking the nums of I, and then I'm checking I equal to 1, I greater than 1, because for 2, if you saw, if we see in this example that we saw, for 2 or the house indexed at 1, we had no I minus 2. So there is no use of going at I minus 2. That is why we are avoiding, right? If so that's why if the I is greater than 1, then we'll do, I minus 2, because if we do 1 minus 2, it will be null out of bound error. So, and we'll take the no take, right? First we take the nums I, current house plus I minus 2, or if we don't rob the current house, we'll take dp I minus 1. We'll take the dp of I minus 1, just previous house, and we'll take finally the maximum of the two and store in dp of I, and finally we'll return dp of nums not length minus 1. As we discussed, the last element of the dp will store the final result. So let's run this program, let's run this solution. Yeah, so test cases are accepted. So let's see how we can space. So let's see the time complexity. So it's only one loop that is running, only one pass, one loop. So order of n, linear time complexity, and the space complexity is also O of n, right? Extra space complexity, that is for this dp. Now can we reduce this space complexity to space of order of 1, means no extra space, no extra space? Yes, let's try to understand this. So if I am at, so suppose I am at, this is our I minus 2, this is I minus 1, and this is I. So what do we need actually at a time? What do we need? So as we saw that either I can take I plus I minus 2, right? The value at I and value at I minus 2, or I can take I minus 1. So at a time I only need these two previous values of the dp. I need these two values of the previous of the, I only need these two variables of the dp. So can I say these as, can I initialize this as previous 2, and can I initialize as previous 1, right? Then I can say, and this is as current, So I can say current equal to max of nums I plus previous 2 comma previous 1. Current, that is nums of I plus previous 2 or previous 1, right? And once suppose this is I minus 1, I minus 2. So once I change from I to I plus 1, I have to change the previous 2. I can change my previous 2 to I previous 1 and previous 1 to cur, and now cur will become I plus 1, right? Because for I plus 1, this will be the previous 1 and this will be the previous 2. So we have to shift our previous 2 to previous 1 and previous 1 to cur, right? And finally, if if suppose I'm the last, I am at the last house, and if I iterate one more time, the previous one will become cur. So previous one will come here at the current, and then previous one will be the result, will store the result of the maximum money got by robbing the houses. So that's how we will optimize the space. So what we will do, we'll initialize one more variable, that is int of previous 2, and we will initialize like -1, and we will do this for, or let's initialize with 0. We'll have previous 2 and initialize with 0, and then we will have int prev1 as nums of 0. Now instead of dp I minus 2, what we can say, we can say previous of 2, and dp of I minus 1 will be previous of 1. We don't need this dp, we'll remove this dp. We are saving our space, right? We don't need to store. Now here what we will do, we'll first store in int of cur, and as I talked about, previous 2 will become previous 1 and previous 1 will become cur. What we will return, we'll return previous 1. So let's run this program. So test cases are passing, so we have space optimized our solution. So thanks for watching this video. Hope you like this video. If you like this video, please share and subscribe. Bye.